wait. Presentation, huh? Okay, what was your first line? Okay, base area. Pi r squared plus 4.2 times 3. Okay, why pi r squared? You forgot the what? Okay, so make the amendment now. Make the amendment now. Pi r squared is for one full circle, but we only have half a circle. So what should we do? Times half? Or divide by 2 are same, right? Okay, let's divide this by 2. Fill in the relevant information. Pi, what is your value for radius? 2.1 square over 2 plus this is 12.6. Okay, so 2.1 square divided by 2. Okay, now that we have the base area, what do we do next? Okay, volume. By 4, yes. Okay, so we have 441 over 200 pi plus 12.6 times 4. Reason I didn't put it as 5SF is because I want to preserve as much accuracy as possible. And you will see why this is important when you receive your test paper tomorrow. Do you have a lesson tomorrow? Yeah, tomorrow. Okay. Yesterday, in the second question, the question at the bottom of the page, first page, where you ask to calculate percentage increase. Remember? So many of you could use the formula change divided by whatever you're comparing with times 100%. But how did you calculate the change? What did you use for the original? Did you use accurate figures, or do you use 3SF here and there, 4SF, or whatever you like, 5SF? So make it a good habit. As far as possible, leave it in the exact form so that you don't lose any accuracy. Next, Manish. What is the first line? Okay, look at what we have done. Look at what Jordan started off with. What should you start off with? Base area. Okay, so we're trying to find the base area. What is that? Is your work on your iPad? Would you like to play it? Yes? Okay. Play it. Show it to me. To me privately, is it? Okay. Okay, I'll pause the recording first. We'll find the big area, the area of the big semicircle. Half times pi radius. What is the big semicircle radius? From here to here. So that gives us a total of 3.5 plus 7. Okay, so from the center over here, seven plus 3.5 squared. This first portion gives us the area of the big semicircle already, half pi r squared, where the radius is 7 plus 3.5. We're going to take away the area of the smaller semicircle, half pi 7 squared. Let's see what we get. 7 plus 3.5, 10.5 square minus 49 divided by 2, 245 pi over 8. This is my base area. Just to make it very clear to you, I'm now shading the base area. Can you understand why there's a subtraction? It's just a big semicircle minus small semicircle, that's all. We get 245 pi over 8. I'm leaving it in terms of pi because I want all the 5 SM. So the volume is just 245 pi over 8 times 6. And you get 577.267. Round this off, 578 cubic centimeters. Is it the same as yours, Manish? The final answer? Different. What was yours? Hey, sorry, I rounded off wrongly. 577. So is it the same as yours now? Okay. Now you take a look at the presentation. Which one do you prefer? Okay, I'll take one question at one time. To address Manish's point, where you say you prefer yours because you understand every single step, is it? But I don't. Because you didn't state down if you stated it, it's okay. Okay? However, the drawback is that there are many calculations. If you have one error, you will end up the whole thing being wrong. That is for checking purposes, right? Okay, so to be careful, if you want to use this method where everything is compressed, summarized, minimal calculation, it is going to be looking like this. Okay, so Veronica, your question, how you get 245 pi over 8? Do you still want to find out? Do you still want to know? I know already, huh? Okay. Okay, so next question. No, yeah. Okay, so base area. 13 times 17 times 2, huh? Okay, then equals to 442. What are your units? cm, meter, square. Volume of cylinder. Continue. What is your radius? 3.5 square times 2. Okay. Right. Okay, then what next? So how? What next? Like this? Yes, William. Okay. Yinjing, got a question. Why do you times 2 over here? Where is your base area? Jovan. face the screen. Yes, Yan Jing, so I multiply by 2. You count wrongly. Oh, you found volume. Yeah, it doesn't tell you your base area. What you found was the volume. So what exactly is the base area and how can we actually use this information here? So what Yan Jing did was to find the volume of the cuboid, take away the volume of the cylinder, which can be done. So let me make the amendments. This is not the base area. This is volume of cuboid. And then everything else will be correct. Okay? But why is it that out of 3 students, only have 1 who started off with base area? That is how I'm teaching you one. Base area. Let's find the base area first. Base area is actually the rectangle. So I'm shading the base area. 17 times 13. Minus away pi r square. So this is the base area in black color. Once you get a base area, just multiply by 2 lah. Volume 221 minus 49 over 4 pi times 2. You get 365.03. Can? Just follow the format, you will be safe. And you can use it for the next set of notes. Next. Find the length of CD. Okay. Base area. Half 724. So 12 times 7, 84. Okay. Good. Then. Okay, good. Okay, very good. So same thing, base area first, equate it to the volume. This time, we're trying to find a perpendicular height CD. Ishan, next. Base area 288. Okay, then. Height 27 mm. Wow, you got an easy question, huh? Volume? Times 27. Okay, good. Next. Radius of circle. Oh, okay, okay, radius. Okay, what happens next? Area of circle. Why do you want to find area of circle? Why don't you just say area of semicircle? Hey, your train of thought very funny. Like. Hey guys, you all memorize area of semicircle as R times pi times half. Okay, not wrong, not wrong. But the logical way of saying it is half times pi R square, isn't it? That's a logical way of saying it lah. Okay, what do you do next? Times 50. Any more? Is that all? Times what? Times 500. What? 98 times 50. 4,900. 49 square meters. 49 cubic meters. What would it be? Yes. Sorry? Change it to meters, huh? Liters, huh? Wow, why you want to make things difficult? Okay. $4.9. Okay, correct. Can. Because 1,000 cubic centimeters is 1 liter. Okay. So any doubts about this? Queries? All okay? Josiah, okay? Okay, Yushin, your turn. Internal dimension of box equals 13.5. Okay. Pause here first. All agree? All agree with the internal dimensions? Can you visualize the question? So we have, I'm drawing the top view. Okay, this is the view, but I remove the cover. There's another cover. If I draw a cover, cannot see anything already, right? The external dimensions 15, 10, 8. This is 15, 10, and 8, including the cover. Okay, so internal dimensions. Do you all agree that it's 13.5, 8.5, and 6.5? No, I've got one no. Do I have any supporters of this? 13.5, 8.5, 6.5. Any supporters? Or is Yishin alone? You know why they disagree? You know why? Don't know. Okay. Why do you all disagree? No. Johan, Joban, the rest. What do you all disagree? Come, Giselle, what do you think? Do you agree with 13.5, 8.5, 6.5? Disagree. Okay, so why? What do you think it should be? What do you think it should be? Do you think it is 13.5? Yes or no? Don't know. Oh, now got chance already, got supporter already. Silio, what do you think? No, why? Understand? So Studio says, no, we have to minus 1.5 on both sides. The internal thickness is 1.5 everywhere, including top, bottom, left, right. So it is not enough to just minus 1.5. We have to minus 3. Get it? Okay. So here we are going to change our internal dimensions to become 12 by 7 by 5. I agree. Why? And what did I say when I started drawing? Why didn't you hear? Talk, talk, talk. Not because your ear bad. You're talking to other people. I even drew it over there, 8, including the cover. Okay, so now, Yixin, you can carry on already. Everything else should be correct now. Just change the numbers only. Next. Okay, so that's part A already. Put in the units as well. So all the cm, cm, cm. Okay, part B. .5. Yes, 1.5. Times 13.5. What? 13.5. No more 13.5 already lah. Okay, so then why 1.5? Huh? Like this, is it? With the adjusted numbers? What is this volume source be? No. Okay, let me help you out. Okay, boys and girls. Can visualize this? This question. Can visualize? You start off with a wooden block. Somehow, you are able to dig out the inside without opening a top. Because Joven is very affected by the top. Somehow, you're able to dig out the inside without opening. And there is a thickness of 1.5 all around. So how much volume was used for the box? Summary, the plan is find the volume of the big box minus the volume of the little box. Get it? Logical? Logical or not? So now our volume will be 15, 10, 8, minus 12, 7, and 5. Okay, so 780 cubic centimeters. Okay, Nicole. Next one, question 5. Okay, wait. AD equals to 240 divided by what? 20. Okay, so we get 12. 12 units meters. Okay, good. Next. Okay, thank you. So base area, half times sum of parallel sides, 1.6 plus 1 times the perpendicular height, which is 20. So the volume, 26 times 12. Any questions? Hey, still got your pencil fixed. What's wrong already? All right. Okay, yes, Glenn. Never mind. Your friends also unsure, still also try. Base area of cylinder. Pi r square. Volume. Area. Recast into a cylindrical metal bar radius 2 pi r square. New base area pi r square. Length of bar, volume, which didn't change, 4 pi times the length. Okay, thank you, Glenn. Okay, understand what's happening or not? Understand? If I don't understand, you're working too bad. So this is what Glenn kind of has on his work, but he didn't leave it in exact form. So for those of you who actually found the base area and the volume with 3SF or 5SF or any SF, no matter what you do, when you come to the final step for the length, your answer is only approximately 45. All right? If you have done any rounding off, your final answer is going to be approximate only. Whereas you left it as in terms of pi, you will get exactly 45, which is what we are looking for. So in this question, put a star. This is the benefit of living in high for working. Get an exact answer. Can I move on? Yeah, exact answer is always better than rounded off answer. Okay, moving on. You want to show me your work? Very soft, huh? Base area, okay, thank you. Okay, I'll just use the visualizer. This one looks clear enough. So let's continue with the simple shape of a cube over here first. Now, cross-sectional area. otherwise known as the base area. We can do that easily. 2 times 2, 4. Right, and now 4 square centimeters. Area of the lateral faces. We have 4 other squares as its lateral faces. So we have this. This is the area of one face. 2 times 2. Multiplied by another 4 of them. Total we get 16 square centimeters. So if I want the total surface area, it will be the area of the lateral faces. Okay, the one highlighted in yellow, plus 2 times of the cross-sectional area, top and bottom. So total 24. For a cube, you probably will think, hey, why not just take 2 times 2 times 6? Yeah, it works for a cube, but it doesn't work for other objects. This is one method that I do not recommend, but I just show you only. This is the logic behind it. Find the area of all the sides, all the different surfaces. Base area on top, base area at the bottom, all the other 4 faces at the side, known as the lateral areas, lateral faces. So then you get 24. This is not what I'm recommending. I am recommending method number 2. So listen carefully to method number 2. This is where it ties in with your previous chapter, why I kept emphasizing on base area. Now in method 2, after you have identified the uniform base, the cross-sectional area, all very proficient at that already. Once you have identified that base area, draw the perimeter of that base area. Draw the perimeter. We are going to find the perimeter first. Then, once you have the perimeter, just take the perimeter times the height. You will get 8 being the perimeter because it's a cube of size 2, right? So 2 plus 2 plus 2 plus 2, you get total 8 cm. That is the perimeter. Take the perimeter, multiply by the height of your prism. You get 16. It is a very familiar number because this 16 over here is the area of the lateral faces that we calculated earlier on. Now we've seen 2 ways that we can calculate area of lateral faces. One is to literally find area plus area plus area plus area. The other is find perimeter multiplied by height. This is the much faster way. Okay? Anybody wants to know why, or are you able to figure it out yourself why it is so? Anybody wants to know why, or you okay just accepting? Your choice. Yes. Then. So anybody wants me to explain why it is the perimeter? The height will be the distance from the base to the base. That is the height. In this case, it's a cube, so everything is just 2. Well, if you're okay, then you can go ahead and memorize this formula. The area of the total surface area is given by perimeter of the base area multiplied by the height. Perimeter of base area times the height plus 2 times of the base area. Okay? Very good. The rest, I hope you can afford. This is where I emphasize a lot on you finding the base area first. Whether you are doing volume or surface area, you will still need to find base area. So you do it once, you can use it in the second part. Because the typical questions will be asking you for both volume and area. No point calculate volume already, then after I still need to find the base area for the next one. Calculate again. So just calculate it once. Good enough. Let's look at some examples. All done with this page? Done? Not done. Glenn done? Then done. Okay, this go and do it yourself at home. I'm more interested in the actual questions. Okay, do this at home. Homework, watch the video, fill in the blanks. Okay, now I'm going to start on one example today. Cross-sectional area of this shape over here is that of a circle. So pi radius is 5 and you square it. So you get 25 pi square centimeters. So same, like what we have done for volume. Find the cross-sectional area, otherwise known as the base area. Now, lateral faces will take this shape. It is actually a rectangle, okay? Visualize that. Okay, visualize your cylindrical bottle having a label wrapped around it. And then when you unwrap it, you get a rectangle. This rectangle has dimension over here, perimeter of base area. Can you see that? When you unwrap the wrapper from your water bottle, the distance, the length of the rectangle of the wrapper has the same distance as the perimeter of the base. And this height is the height of the prism. So the area will be perimeter of base times perpendicular height. So what does this look like? 2 pi r times the height, which is 8. So we get 80 pi square centimeters. So the total surface area, we've got 2 of the circles, 2 of them. So 2 times of 25 pi plus the area of the lateral face. So we get a total of 130 pi square centimeters. Of course, since they didn't say leave it in pi, leave it to 3SF. You get 408.407. Round it off, 408 square centimeters. I will now highlight what we are calculating. So the yellow color portion, 2 times of the cross-sectional area. That rectangle over there is given by our 80 pi. Okay? So your job is to watch that video in that with that QR code.